All right, so today we're going to start shifting quadratics. We're going from vertex form to standard form. So remember, vertex form is your y equals ax minus h squared plus k. Standard is y equals ax squared plus bx plus c. So we're going from one of those to the other. All right, so if you look, there's our given vertex form of our quadratic function. Y equals 5 times x minus 3 squared plus 7. So how are we going to get that into standard form? Step 1, you want to rewrite your perfect square as a trinomial. So remember, when you have anything squared, it just means that we have it twice. Even if it is in parentheses, it doesn't matter. That's what that means. So if we rewrite it, y is equal to 5 times x minus 3 times x minus 3 plus 7. What we need to do is actually multiply that out. Remember, we decided we like the box method. So if we do our box, we get x minus 3, x minus 3, x times x is x squared, negative 3 times x is negative 3x. Come down here, it's the same, and then negative 3 times negative 3 is a positive 9. So now if we rewrite them, it's x squared, and just write them going across, minus 3x plus 9. You need to combine your like terms. Well, if you look, we have a minus 3x and a minus 3x. We have an x squared. Those go together. And we also have a plus 9. So when we rewrite it, we have x squared, and then you would do negative 3 minus 3 would be minus 6x plus 9. All right, so we see this is our new trinomial, so we're going to replace this. So this is our new trinomial. So instead of having this, now we're going to have that. So if we replace it, like step 2 says, replace the perfect square with our new trinomial, we get that y is equal to 5 times x squared minus 6x plus 9 plus 7. So we've replaced it. Step 3 says you want to distribute the a. So if you distribute the a, which remember your a in this case was the 5. So once you do that, you get 5 times x squared is 5x squared. 5 times negative 6 is negative 30. Then don't forget your x. 5 times 9 is a plus 45. And then we still have our plus 7 at the end. So we're at step 4. And it says combine like terms. So we have 5x squared. We have minus 30x. We have plus 45 plus 7. So the only two that will be combined are green at the end. So we have y is equal to 5x squared minus 30x plus 52. So that's our finished product. This is it in standard form. So we've got it in standard form. Now it says identify attributes of our quadratic function, because we can't forget how to do that. So when we go to identify our attributes, we want to go to new document. Do you want to save? Say no, and go to add graphs. So if we type it in, 5x squared minus 30x plus 52. What we want to do first before we check for our attributes is see if it matches. So it doesn't appear on my screen, so you want to do menu, window zoom, and if you go down to that letter, the A, it says zoom fit. Wherever your graph is, it should appear. So here it is, and that's our standard form. So what we want to do, let's type in our vertex form and see if it matches. So hit tab, and then you want to type in what they gave you up at the top. So it's 5, open parentheses, x minus 3, close parentheses, squared, plus 7. So then hit enter. And if you look, they ran right over the top of each other. So that means that they're a match. So that means we did it correctly. So now let's go on to do our attributes. So we want to find our vertex. So it's menu, analyze, and it had a minimum. Oh, it says pick which graph. Let's pick one of them. So now you set your lower bound. And then you set your upper bound. And if you look really hard, it says 3, negative 7. So our vertex will be 3, negative 7. So while we're at it, if we look, let's look at our axis of symmetry. What you need to remember is your axis of symmetry is the x value of vertex. So in this case, our equation would be x equals 3. So we have x equals 3. Then does it open up or down? Well, if you look at your picture, it opens up. It says number of solutions. Well, if you look at it, and I know there's a lot going on, it never crosses the x-axis. You can also tell from the table, if you go Control T, the lowest point is 7. So it never crosses, so that means it has 0 solutions, and it has no x-intercepts. We can write none. And then you go for y-intercept, so it's just wherever in the table it says 0. So it's going to be 0, 52. You can also get that from the C value. All right, so let's turn it over and try the example on the back. So we have the same thing. So step one is that you replace your perfect square root, your perfect square, and you write it out twice. And then you have to solve it. So do your box method. You're going to do x minus 8, x minus 8. You have an x squared. Negative 8 times x is negative 8x. Negative 8 times x is negative 8x. Negative 8 times a negative 8 is a positive 64. So when you rewrite it, you have x squared minus 8x plus 64. If you go to combine like terms, you have an x squared minus 8x plus 64. So when we combine, we have x squared. Negative 8 minus 8 would be negative 16x plus 64. So step 2, go back in and you replace it. So now you have negative 4 times x squared minus 16x plus 64 plus 5. Step 3 is you want to distribute your a value. So you get that it is negative 4x squared. Negative 4 times a negative 16 is positive 64x. Negative 4 times a positive 64 is a negative 256, and then bring down plus 5. From there, once again, you have to combine your like terms. So here's my x squared. Here's my x. And then I have 2 constants this time, so that's what I'll be combining. So I have negative 4x squared plus 64x, and then negative 256 plus 5 is a negative 251. So let's graph it with our vertex form and see if they match. So let's not save, go to add graphs. So I'll graph my first one, negative 4x squared plus 64x minus 251, and hit enter. And then hit tab so you can get the bar up there again and enter the vertex form, x minus 8 squared. Oops, what did I do? No, that's not one. I need to add the plus 5 and hit enter. And if you see, they lay on top of each other. So we have our graph. So what I want to do, last time it said we had to delete. So go back up and delete the vertex form. So then all we're dealing with is one graph, because now we still have to identify our attributes. So let's find the vertex first. So menu, analyze graph. It's going to have a maximum because in this case it's opening down, which we'll fill in that part. Our vertex is 8, 5. sorry if you can't see that. It's 8, 5. My vertex is 8, 5. It's opening down, so it had a maximum. Let's find our y-intercept. If you go control, actually, what I want you to start remembering, your y-intercept is that c value. I guess it would help if you could see, right? So that is 0, negative 251. Your axis of symmetry is your x value, so it's x equals 8. In this case, there are 2 zeros, so control T. If you look for when, oh, they're going to be, okay, control T. If you look, they're not going to be perfect. It looks like they're falling between 1, 2, 3, 4, 5, 6 and 7, and then 9 and 10. So there are 2 zeros, but they're not perfect ones. And we'll go over that. They're between, let's see, 6 and 7, and then between 9 and 10.